Good morning, sir. Good morning, everybody. I hope that I'm audible.
Yes, you are audible.
Honorable Sir, Professor Kumaresan sir has joined us. We will soon begin this session at 10. Sir, can you hear me, sir?
Yes.
Thank you, sir. We let people join.
Good morning, sir. Good morning, everyone.
Good morning, Anmol. We will start at 10 exactly. In the meantime, I request you all to please keep your microphone and camera off at all times unless you are requested to speak. Otherwise, you'll get just a lot of people speaking at the same time. That will not be ideal. Vidhi is going to say about these things just in a moment. We may start, please.
Okay. A very warm good morning to one and all present over here. We welcome you all in 33rd interactive session of Janman Vivechan on the topic How to Learn Mathematics. Our honorable speaker for today's session is Professor Kumaresan, the Director of MTTS program. Sir has already joined and is here with us. We heartily welcome you, sir, for the session on this virtual platform of Janman Vivechan. We are very fortunate that we got the opportunity to listen your valuable insights. I am Riddhi Kumari, currently pursuing BSc B.Ed from Central University of South Bihar. As a host, I would like to share some important instructions with the participants. As the participants are joining from different universities and colleges, you all are requested to follow the digital etiquettes and maintain the decorum of the virtual room until and unless you are requested or asked to do so. Kindly put your suggestion and queries in the chat box, which will be conveyed during interaction session by our moderator. Now, I would like to invite the introducer of today's session, that is Chandrasekhar Kumar. Chandrasekhar, over to you.
Thank you, Riddhi. Pleasant good morning to you all. I am Chandrasekhar Kumar, an undergraduate student of Central University of South Bihar. We at Janman Vivechan welcome our honorable speaker and guest, Professor S. Kumaresan, sir, respected teachers and learners from different universities, to our much anticipated 33rd online session on the topic How to Learn Mathematics. I would like to heartily thank Professor S. Kumaresan, sir, for gracing us with your presence. Your insights are the beacon that will illuminate our path towards knowledge, understanding, and discovery of diverse aspects of learning mathematics. Sir needs no introduction, but I would like to share a short intro about Sir. Professor S. Kumaresan is an eminent name in the field of mathematics. Sir, as a great mathematician, with area of specialization in differential geometry, global analysis, and pedagogy, has been teaching for decades with great passion and enthusiasm with his innovative and new methods. Sir is the director of MTTS, Mathematical Training and Talent Search Program from 1993, which is supported by the National Board for Higher Mathematics. MTTS Trust organizes camps and programs at colleges and university level with the aim of inspiring and motivating young talents toward mathematics by giving them a better perspective of modern mathematics. Sir has been the member of National Board for Higher Mathematics. He has visited and held numerous positions as various leading global institutes and different international committees. Sir has authored and co-authored a large number of books starting from BSc to research level. Now, to all the enthusiastic learners, this platform and absorb. We encourage active participation, thoughtful discussion, and willingness to challenge. As we embark on this virtual voyage, let's remember that knowledge knows no boundaries. We all come from diverse backgrounds and each of us bring unique perspective, making this learning journey all the more vibrant and profound. Now, I would like to call Chandra Prakash, the moderator of the session, for the further proceedings. Over to you, Chandra Prakash.
Thank you very much, Chandrasekhar. Uh, Good morning, everybody. I hope that everyone is doing well. Good morning, sir.
Good morning.
Pleased to have you, sir.
Did you hear me? Good morning.
Yes, sir. I'm able to hear you, sir. Good morning, sir. So, our platform is basically managed by students of Central University of South Bihar, Janman Vivechan. we try to engage in dialogues in various fields, and in our department in Central University of South Bihar, B.Ed. So many of us are going to be teachers in mathematics and many other subjects. Some are going to be in schools and some are in colleges as well. So regarding that, I thought that I should invite you to speak with us, to interact with us, and thankfully you agreed. Uh, I was in MTTS 2023 program, and at MTTS I learned quite a bit about the teaching methodology that in theory we read about them, that it should be done like that, it should be done uh, this way, that way, discussions should be there, things all be there. But how is it done in practice? I was able to see in MTTS program, and the students pursuing MSc and BSc here in our university as well, they view this subject as very cryptic. And many of us, I know them, that they have gone out of doing, right? Especially with when it involves approaching with the proof, because there are very rare computational tools. The formulas don't work here in this world, so we are used to plugging formulas and getting answers. So regarding that, what will you say to the prospective teachers that are going to teach mathematics, especially in schools? Sir.
Is that a question addressed to me?
Yes, sir. That is a question addressed to me, because we are basically teachers, prospective teachers. So, and most of us are in Central University of India, that people are joining from CUSD. They are from BSc based course, and they are going to be teachers in mathematics and many other subjects. And most of the people joined are in mathematics. What do you expect from teachers at school level? I know that you have been very active, and I have seen you in real life. So I have met you, so I know what is it in the higher mathematics. I have some idea, but I have been meaning to ask you, what do you expect from teachers at school level, especially from these trainee teachers that have joined us?
See, at the school level, one has to understand the purpose of mathematics at school level is essentially for utilitarian purpose. Mathematics is a very useful subject. That's the impression all of us have. Okay, even illiterate people do have. Okay, so at the school level, what main aim of teaching mathematics is students become comfortable, okay, to carry out daily life where mathematics is needed. Okay, there it's not very much necessary. You go into too much of theory, why it is being done that way, etc. So one has to make them proficient. And let me just give some example. I will also come to the concrete way of doing things. Mathematics at school level, as you said, is formula based, algorithm, what one usually call algorithm. You do this, you do that, then you get the answer. Okay, you don't explain why the algorithm always works and why it gives the correct answer. That is theory. Like all of you know Euclidean algorithm, right? So if you do it, okay, you get a GCD of 2 integers, very good. But how do I know it always works? That's where the number theory comes. It gives an explanation of why it always achieves the purpose. That is theory. So this is the difference one has to keep in mind. Coming close to school level, even at the second, third, fourth standard level, try to think of it this way. When we take 2-digit numbers, multiply by 2-digit numbers, we start with unit place, right? 28 times 14, then 4, 8, and 4, 2, like that, whatever. Okay. But when I want to divide 28 by, so let us say 282 by, we start with the highest place. In this case, 100th place. Okay. Do you want me to explain why it is done that way? Even at the 10th standard level? No. Even at your BSc level, did any teacher mention that to you? Why you are doing that? No. At MSc level? No. But one has to think about such things. So this is how various things happen. Okay. But on the other hand, let us try to understand school mathematics. What I have found in my experience, the last 50 years or so, is that students don't have inherent dislike or hatred or fear for mathematics. They don't. When do they have? Because of teachers. They try to say, do it, and you cannot make mistakes. And second thing is, the first time when students really have problem is not in addition or multiplication, even though it may be a problem for many people, but not everybody learns at the same speed. What is taught at 3rd standard, the student may learn it in 5th or 6th standard well. Okay, somebody may even say I learn it at 2nd standard itself. It all depends. Okay, the way they feel comfortable with mathematics. But eventually everybody can learn. But on the other hand, we have some fixed syllabus. We want 3rd standard students should learn that, like that. So the first time the students have problem with mathematics is fractions. Okay, and again, if you look at multiplication of fraction, does not give any problem. A by b into c by d will be ac by bd, easy for them. But you want them to do addition, a by b plus c by d, then they think a plus c by b plus d. That's the first time they have a problem. Okay. Now, why can we do it? Why can we surmount that? Okay, I'll come to that. Okay, please remind me, because I just want to illustrate some other things. And second is usually in the, I hope in 7th or 8th standard, when algebra is introduced. Okay, all of a sudden you write down 5x squared plus 3x plus 4, and you ask them, x is just something, don't worry about it. If you want, you put a number, and you how to add, multiply various things. They don't have any idea why you are doing. Okay, if fellow has survived the 3rd standard fractions, when he comes to 7th or 8th standard, he is stymied by algebra, so-called algebra. Okay, he doesn't even have problem with the 4x plus 3y equals something. The problem is polynomials. Okay, you just deal with something like powers, you don't even understand what it is, you want to add, do. Because you simply teach. You like the way I don't have to know how a car works, but you train me how to drive it. If my purpose is only that, I should be happy. Okay, here there is a kind of dilemma with students. Some of the students, okay, who are also a little curious, may not be extremely talented, they want to know why we are doing that thing. Okay, and the fraction itself we do not explain. Okay, for example, if we don't take time to explain 1 by 2 is same as 2 by 4 is same as something like 6 by whatever, okay, 12, etc. We don't explain, and we don't want to see, give very geometric or even physical examples what 4 by 5 means. This kind of thing we don't. We immediately want to define something and do that. This kind of algorithm is the one which is creating problem. Now, as you rightly remarked, Chandra Prakash, I deal with only college and university level, research level mathematics. But I think about 20 years ago, I went to a small village in Tamil Nadu, and the principal of the Tamil Nadu, okay, that school, Tamil Nadu school, knew about me very well, and she said students have problem. It's essentially 1st to 8th grade, 8th standard. Then she asked me, okay, I said usually this problem starts with the fraction. She was very surprised I knew about such things. Yeah, okay. I mean, that the problem, of course, I knew about fractions. Okay, what she was surprised is students' difficulty.
Sorry, if my question may please interrupt.
Yeah.
People want to see you there.
Okay, sure. Yeah. Right. So, Then I told her, is there any batch of students who are not taught fractions? Okay. She, for two, what you call sections, some 3A, 3B or some such nonsense, they have not been taught. So, and I talked to them in Tamil. I started with what is the meaning of fraction, and slowly, okay, everything less than an hour. Okay, went to equivalent fraction. Okay, then I don't think they have mastered, but they understood when I wanted to say, how will I add 1 by 2 plus 2 by 3? Turning into equivalent fractions and add. They more or less certain. After 2 years, when I went there, when I met, she said that particular set of students were doing extremely well in mathematics. So the point I'm trying to say is, okay, within the given time, we can spend something where it has to be algorithm, where students have problem. At that point, make them comfortable with that, why we are doing. Okay, this seems to work very well. The same thing with even if you identify the problem or difficulty faced by the students. Okay, we forget we are students once. Okay, how we struggle. Okay, now that I become very comfortable, I keep doing. If you all of you have experience, for example, when personal computers started, okay, somebody becomes proficient, you ask him to solve your difficulty, he quickly tuck, you do it. Okay, but you will not try to explain how to do it, so the next time you can do on your own. And the same thing with mobile. You ask somebody, how do I take this screenshot and send to somebody how to share? That fellow will quickly do it and do it. But you will be at a loss. This is what is happening everywhere. So one has to understand the first thing to be a good teacher is attitude. You want to help students or your audience to learn. Usually teachers go with the thing, an aura that I know all, omniscient, I am an expert, so I want to show, okay, kind of show off my expertise to the audience. So that's where the problem starts. This has nothing to do with I'm on a school level, high school level, or secondary school level, or college, or university research level, or even research level conferences. It's the same thing. In a nutshell, two things. One, the correct attitude. Second thing is, of course, you have to be competent. Okay, you should have learned the subject well. Okay, but the first thing is, if your attitude is good, then even if you are not learned well, you will put effort to learn it so that you can deliver. In fact, I believe that, B.Ed courses, etc., they teach a lot of things. How many, as you yourself said, how many are actually implemented, how many are used, how many are really kind of what you call of practical use is good. But my simple thing is, as anybody said, the first thing for any prospective teacher is the attitude. Your main purpose is to educate, to facilitate the learning process of your audience. That's it. But I think I expanded your question a little more and went ahead. But I hope it's okay. It answers in part at least your question.
Yes, sir. It was quite a comprehensive take on that. Moving further, I have some queries from the participants themselves. While registering, I have asked them to put queries. We'll get to that. There are some specific queries. But before that, I have some problems of my own.
Yeah.
I tend to get daunted by notations.
Yes.
And reading from books, like we usually in self-study, usually we have to do self-study in this because we don't find quite good classes on that. We tend to. So two things we do: book reading, and we go on YouTube and find such theorems is there. Let's do Weierstrass theorem, whatever theorems we are learning in the course. We go on the YouTube and try to find sources on that. And people tend
Your mic is muted. At least you are not audible.
Okay, am I audible now?
Yeah, now yes.
Yes, so we tend to go to YouTube, especially
Yes.
in first, second year when these things. In first semester, we have something called introductory mathematics, which is kind of similar to what foundations in level O is there. Okay, so some number
I
theory
think
and
almost
set
all
theory.
courses similar nature across the country is
Yes.
inspired by
Oh,
our foundation course. Okay. In
so,
fact, I am proud of
so
that. When the publisher asked me whether it's a textbook, I said it will not be, but the courses will be created and this will become a textbook. Okay, in less than 5 years' time, it started happening. Yeah.
So that yes, that course of introduction mathematics, GCD, set theory, number theory, and set theory, mostly it is there.
Mm-hmm.
So about when the students come in first semester and they go about reading about it, usually they want to find videos on YouTube. Even though the teacher has been explaining in the class, they tend to go and find, not read the books. And usually the main problem, the main hurdle that I foresee I had when I tried to go to the books was notations. Like,
Yeah.
I'm still afraid of notations. They look kind of funny coming from 12th grade, and it is very daunting.
Yeah, sure.
So what do you have to say to in that situation, sir?
What I find from my observation with the students and also reflecting upon myself as a student when I was, is if you look at it, usual classrooms and textbook, okay. If you notice in my books, I will ask them, okay, this is not exactly the same. Please send some time. I will even say about when I introduce a notation. Yeah. Okay. And I don't think any other book does such things. Okay. In classrooms, I always do that. So the way to get rid of your fear or whatever you call discomfort with when the notation is introduced, you ask yourself questions. Okay, what does it mean? Take some time. Try to create something on your own. Okay, whatever it is. For example, when I say x cross y, then you take some x and some y. Try to write down x cross y, and do not worry about very complicated examples. Look at simple examples so that it gives you an idea how to do that. Okay, this is the kind of thing. For example, if you give me any particular notation, you had a problem, I will take. For example, I will tell you. Even you are in level 1, if I remember right? Chandra
Yes,
Prakash?
sir. I was in level 1. Yes, sir.
Right. See, for even level 1, I did that. Yes, I remember that. Do you remember when we did inner product? I started with what is summation xi whole squared. How do I deal with that? Okay, teachers will immediately use it. Whereas you might have seen, I asked you to write x1 plus x2 plus xn, multiply x1, then you see that there is a cross product xi xj, and therefore it should be double summation xi xj for I and j vary from 1 to m. This kind of thing. It took time. I asked you to do that. In fact, if I remember right, I even asked you x1 plus x2 plus x3 into something. Same thing. Multiply. This kind of small things you take. Whereas if you simply say summation xi whole squared, it looks obvious. And you go ahead. When it comes, you don't, then you start wondering, to extra A, B, kaisa aega kind of questions you have to ask. Okay. So it takes time. So whenever there is a notation, spend some time. What does it mean? Do that, you will become very comfortable. Next time when it comes to notation, you know how to deal with it very quickly. As like anything, it's a starting problem. So the best way is whenever there is a notation, spend little more time. Don't be in a hurry to jump ahead. Second thing, look at some concrete example if possible. Try to work out what it is. It just takes about 20 to 30 seconds extra. Yeah. Have I answered your question? Yeah. If you have any specific thing, you tell me. I will tell you how I will spend time to learn the notation. Yeah.
So,
because it will be good to demo. I gave some demo on my own, like I'm on summation xi whole squared, and similarly how to write a system of equations, etc. But if you want something more, something specific, you can tell me. Yeah.
In something specific, I'm not getting right out of my mind, but I think audience will have many such queries
Yeah.
about that, because the most of the questions that I have gotten from audience,
Okay, sure.
they are about writing proofs.
Yeah. Writing
So
proof is an art.
yes,
Yeah, any writing is an art. Oh, even scientific writing is much more, because now you have to be technically correct. At the same time, you should also learn to write well. See, again, let's go back. Try to understand everything in perspective so that you. Sanjamma, Sani Jamma, right? Or Sanji Amma. Sanji Amma Samsudin, please. Yeah. Let's go back to the communication aspects of human race. What came first? Thinking came first. Okay, without words also we thought about something. Okay, we may not be able to express in words, but we thought about it. Next thing is, when I thought about, I wanted to communicate to you, then I developed some kind of voice, vocal. Okay, notice that it's again a symbol. When I say it's a symbol, symbol is a symbol. The word symbol is a symbol. Okay, for what I have in mind. You understand that? Okay, don't get into philosophical thing, but try to understand, think a little more. So, when I want to say, oh, I saw the sun today, okay, everything is sun is a symbol. Okay, you understood that when I said sun, right? Because you have been exposed to that. Okay, so next thing came oral communication. That is where I developed a language. Okay, so I thought about something. When I wanted to communicate my thoughts to my fellow human beings, okay, we all as a group joined together and developed a language. For my thought, I developed something. For your thought, you developed something. Then finally, we kind of more or less standardized. Okay, all of us will refer to sun as sun. Okay, not as moon, or as star, or as a meteor, or as a mud. Okay, so we learn. So we agreed to that. That is the purpose of symbol. So language is also a symbol. Okay, it's a symbol for your thought. Okay. Next, so what are the easier thing? In my opinion, thinking is easier. In spite of our education tried to kind of blunt it, spoil it, thinking is natural. All of us are born with a thought process, thinking process. We are all thinking machines. Second thing came language, oral communication. Now suppose Chandra Prakash is now far away at Bihar. He writes, then he wants to ask a question. There is a Zoom or Google. Earlier days, what did you do? Then you develop art of writing. You developed another symbol. Okay, and I want to write sun, then I develop SUN to denote it. What my voice, the pronunciation sun, is again, that's already a symbol. That sun symbol is again represented by SUN, that's another symbol. Okay. Please, we are all science students. Please think about, it's not philosophy. Okay. The thought process is very important. So, I used it to communicate. But notice that by writing, when I'm trying to communicate my ideas to you, it may not be as effective as if I talk to you directly. Because if I talk to you directly, okay, there is a lot more time, okay. I can spend some 10,000 words, whereas when I want to write, I'm able to condense it to 500 words, number one. Second, when I'm talking, you can see a lot of hand gestures, my eye movements, my body language, all of them add to convince you of your conviction, okay. My conviction, all these things are reflected. My voice, intonation, accent, everything helps you to accept. So the second thing is oral communication is always easier. The difficult thing is writing. What I have to explain in 5,000 words, I have to write it in 500 words. Because writing takes a lot of time. It's always difficult. Unfortunately, writing is always difficult. Unfortunately, our exam system places only importance on writing. Okay. Now, how do I? So I explained the reason why writing is difficult. I hope all of you understood that. So believe me, thinking is easiest. Okay, in spite of whatever people say, thinking is the easiest. You keep thinking 24 hours a day. Even when you sleep, you think. Okay, right? You understand that, right? You are during rapid eye movement, REM sleep, you process your information which you experience which you got on the previous day. So thinking is very natural. Okay. Now, how do I develop writing habit? The first thing I would say, you start with proofs which are 2-line, 3-line proof. Try to write it. For example, that's why I like something like very elementary number theory, which are much easier. If A divides B, A divides C, A divides B plus C, that's a 2-line proof. So I write B equal to some M times A and C equal to N times A, therefore B plus C will be MA plus NA, which is M plus N times A, therefore it's a multiple of A, therefore this is a 3-line proof you can write. So try to learn to write simpler proofs first. Unfortunately, teachers and very quickly go through, you simply copy. That is the place where it's going to be teachers in either at school level or higher secondary or college or university level. So please do that. When you give, they'll simply write their post. Okay. Suppose there is a multi-story building, lot of shopping complex, residential places, showrooms, this and that, parking area, everything. Okay, lot of things. There is a fire breaks out. Fire service comes. Do you think they know the entire building? How will they know where to go, how to look for things, how to rescue people? I think they should extinguish first. How will they come to know? See, these are things these are not taught. Ask is they will ask for a blueprint of them. Okay, they have been trained to do that. So they will see, okay, water hose is there, this is the place, this may happen. Okay, this is the exit, these are the things they will. Okay, so that the smoke and fire can quickly come out so that it doesn't kind of suffocate people, smother people. So they will look at all these things. So the same way, when you look at a proof, big proof, you try to look at a blueprint. What are the main steps? Each step usually a small problem, as I said, a 4-line, 5-line, maximum 8-line proof. You master that. Then when you write, you will see, okay, this is the first step, and I have to make this claim and prove this. After that, I have to make this observation and deduce something like that. You don't do that. What you do is, the way you learn, line by line you check, you want to remember and write, so you get confused. Your writing is never effective. I just want to give some 20 seconds for all of you to think what I said. Okay? No questions for a while. Let's keep it 30 seconds.
If you think about what I said about proof writing, it takes time.
So coming back to, so the art of writing is an art, and if you want to write something, we also technical material. Master the art of writing is some short proofs. Okay, in analysis, algebra, wherever, number theory, element theory, you will have such things to practice. Do that. And second thing is, look for a proof which is slightly longer, which will be usually your problems. Think of them. Those problem solution will be, so usually it will be 7-8 lines. Try to learn how to write it properly. After that, big proofs. For big proofs, the basic idea is go through the proof, try to understand what are the major claims, ideas, or steps. Okay? Okay, the way you look at the proof and the way I look at the proof, the way Chandra Prakash looks at the proof may be different. That doesn't matter. The proof is yours now. You want to write it. So don't worry about what Kumaresan thinks or Chandra Prakash thinks. What they think as the main ideas. Don't worry about that. You develop your own idea. Okay? And then write it. Make smaller pieces. Each piece is a second step. Such things. Learn. Just to practice for less than a month, you will see you can write mathematics much better. It doesn't take more than a month. The only thing is spend about 20 to 30 minutes every day for a while. If you want to spend 30 minutes a day, you don't even need 1 month. Alternate days will do. About 15 to 20 such attempts will already make you reasonably comfortable. Then, as I said, it's an art. The more you practice, the better you are. Okay. So how many of you think this makes sense? Can you raise thumbs up or thumbs down? Okay. Is there a way to count Chandra Prakash? Things to me. Okay. I have a lot of experience.
What did you say, sir?
Those of you who practice, convey your achievements or performance to Chandra Prakash, and Chandra Prakash will inform me. Okay. That's what I said.
Yes, sir.
Because I have a lot of experience. Because many of my students, okay, they were praised for their way of writing. Okay. Where did you learn to write like this? Okay, they all quoted me. This is a very simple thing. It just needs a little practice. But remember, nothing is perfect. Even some of my thing I write seven times also. Okay, I think I did very well. After 2 years, when I look it up, then I look down upon it. Then I want to rewrite. Okay, this happened. Okay, this happens. But at that point of time, it is good. Everybody accepts that. Have I answered reasonably well?
Yes, sir. Your answer quite comprehensive. I think your internet connection may be a little.
Mine?
Maybe mine. I don't know. I cannot see.
Yeah.
I think trouble hearing your voice is.
Oh, is that right? Okay.
Off and on and off.
Oh, I see. I think Google tries to shift my mic between the webcam mic and this headset. Earlier, about 2 months, also somebody had complained when it was Google Meet. Zoom doesn't do that. Zoom fixes that. Okay. Yeah, are you able to hear me? If you don't hear me, please tell me.
Yes, sir. We are able to hear you. It's just that the audio is not that clear.
Just because I think you have a low internet connection.
Possible, mine is supposed to be 100 Mbps, but one can never be sure. Okay.
Sort of open the session. Is also one audience. Mukesh from Isaac Tirupati asked to ways to overcome first look bias. The first idea that we see that occurs to one upon looking at a problem or a proof or a definition seems to stick harder. It seems to stick, and then after that we are unable to think alternative ideas. What else could happen? That doesn't. So the first look bias, how to overcome that? That is the question from Mukesh.
Yeah, that's a very good question. All of us suffer from bias. Okay, so we have preconceived notions. With that, when we look at something, then we think that we understood. Then after that, it becomes very difficult to come out of that. In fact, in my career, that's what I call as a mental block. You might have seen you have a problem, you don't understand something, you go to a teacher, the teacher repeats the proof. Okay, that doesn't enlighten you. That doesn't help you much. Whereas, what I find is I ask you to explain the proof, then I understand where you have difficulty. And then I understand you have a mental block. Okay, I'll give a very specific example which happened about 40 years ago. I was in one of the reputed research institutes in the country, the most reputed. Excuse me, I have a call. Just one. Yeah. So that person was trying to learn what is called Fibonacci theorem, product measures, etc. He had problem. He was my junior. He came because I was already known as a good teacher, so people came to me. I was trying to explain. It didn't make sense because those people are usually very intelligent. When I asked him, you explain. Then he started explaining, then I understood the problem. In MTTS level O, we take care of that, for example. If I have two sets X and Y, look at the Cartesian product X cross Y. If A is a subset of X, B is a subset of Y, then A cross B is a subset of X cross Y. But not every subset S of X cross Y is of the form A cross B. Okay. In a foundation course, we teach this, we give examples. Many of you may not even be aware of that. Try to understand that. Okay. This is a problem. Once I understood, then I explained. Okay. I gave an example where S is not of the form A cross B. And then after that, it was very easy. Think of it as a pipe, long pipe, drainage pipe. You think there is a block. Okay. The wastewater doesn't flow. Then what do? You can keep on pressing, but on the other hand, the correct thing is try to see where there is a block and isolate the block, remove the block, then the water flows easily. You understand? So many teachers, what they do is if the students have difficulty, they keep explaining again and again and again. Okay, it's like water doesn't flow, keep on throwing water and try to push it with the stick or something. Okay, of course stick might remove, but still. Okay. The better way would be try to identify where the problem is. Usually, this is a preconceived notion, as you said, as what is his name? Some student said. Okay. When you read something, a concept or a theorem, you already have some idea. Then it is like additive group, okay, roots of unity, etc. Then you will think every group operation is commutative. Okay, till I give an example of non-commutative. Of course, the teacher immediately explained that, but think of it, okay? This is a kind of mental box. So, I tend to believe, okay, whenever AB is same as BA. If you keep giving only such examples, I tend to believe. Okay, when you give a proof where you are making sure that AB is not equal to B and therefore you have to be careful with the proof, I don't understand. I think there is something wrong. The reason is, I tend to believe in every group is a belief. I give a very simple example to make you understand in your context. Right. The student from Tirupati, right? Manish or what's his name? Somebody. If you want, give an example. I will give you the thing where the problem is. Okay. This happens all the time. So the best thing would be to look at a variety of examples and try to understand, be it a definition or be it a theorem. Even in the theorem, you will realize, okay, we assume certain things as extra hypothesis which was not needed. So the best way will be to come with a concrete example so that I can explain. Okay, this should be a demo session so that you will know. For example, everything I came to some concrete mathematics, explain that. Okay, so it's up to you. Now, if you are mature, then you should fit that example in your mind and revisit your example and try to understand better. Okay. Otherwise, we are talking only in abstraction. Whereas the abstraction I talked about and then I gave in terms of example. Okay, please understand. For example, if I say something like continuity, right? Okay, in a general topological space, you are all BS, so I have to be sure about something. Okay. For example, you look at metric space. The moment metric space is written, student will write mod x minus y, distance between x and y. Why? He only knew R distance mod x minus y. When a general metric space, even I was in level 1 this year, some student wrote mod x minus y. in an abstract metric space. See, these are the kind of things only with more examples, you spend time and work on that. Okay, I'm through. If you want, yeah. If you want further detail, please ask me. Can somebody ask questions, Chandra? Because I want to know whether the mistake is in my internet connection or in your internet connection. Ask the person who asked the question to open and ask me. Let me see.
Mukesh, are you here? I think he or she may not be here. I follow up on that in a sequence of functions, we have two types of convergence, point-wise and uniform convergence. Like,
what is it?
Usually, in sequence of functions.
Yeah.
The first thing we studied in level 1 analysis.
Yeah.
That we have two types of convergence, that point-wise convergence and uniform convergence.
Right.
In that, usually, before I had gone to MTTS, we didn't have any.
Chandra Prakash,
Yes.
I just want to ask others, how many of you have a problem with my audio? Those of you who have a problem with my audio, please show thumbs up, thumbs down.
Sir, your audio is clear.
Now it is clear, sir. It is
right.
Clear.
Because that's a problem, because whenever Chandra Prakash speaks, I can hear there is a problem in hearing him. His connectivity seems to be the problem for me.
Yes, sir.
See, everybody says you're perfectly audible. So that's the reason why I asked Chandra Prakash, the easiest way, since you have the list of people, okay, you call them out, let them talk directly, ask the questions. Is it okay? Let's try it out. If there is a problem, we'll revert back.
Okay, sir. That's what we are going to do.
Call out the names.
So, we are opening this session for direct questioning. Yes. So, Mukesh Kumar's question is over. So, and if he is here, please ask the question. Yes, and Riya Vasak from IIT Ropa asked that I feel difficulty in imagining, I don't know what stated to write, the definitions and how to proceed with the theorems and problems. Imagining, visualization. Sir.
So you have problem with visualization. Okay, give me an example. Which you have problem with visualizing.
Is she here? Okay, Abhishek Ben has raised. Please.
Good morning, sir. You told about proof writing, or that whenever we get a theorem or some result, what we do is just read the proof and try to understand it. But my question is, should we first try to prove it on our own? And if we try this, then up to what extent should we try it? Then after we see the proof or whatever, because I asked my seniors and some PhD seniors, they told that what they do is took some problem and spend some 1 or 2 or 3 months to approach its solution, because it is not available anywhere, and sometimes they realize that they can't achieve what they want by that way. Then they again start from scratch. Then for us in our coursework, up to what extent we should try on our own, and then we proceed with the given proofs?
Yeah, this is a good question. Let me put it in a slightly, as usual, larger framework. See, finally, mathematics, you prove a theorem or do something or other, it finally finds out saying, I am solving a problem. Right? The only thing is that for formulation of the problem, that's a statement, that could be a theorem, which I mean, after a lot of work, you arrived at it, but you still have to give a proof. Okay, otherwise, it's also a problem. It's a big problem. That's it. Good. Now, the question is how to do that. The easiest thing, as you said, is before reading a proof, before reading a solution, you attempt on your own. But how long? It all depends. It all depends on what? It depends on how much time you have on hand, right? If you are already studying a course, usually you will be something like 5 courses in the semester, and lot of assignment, this and that, social activities, everything. So how much time can you have, right? So it's not possible that for each and every problem or each and every theorem, you will have time to spend like that. But on the other hand, what I would suggest is every day you take only one small piece and do it, and let's say 5 minutes, 10 minutes, 15 minutes, and then look at the proof and try. Then you will see how to think. Oh, this is the point I missed. Or you might have even got through the proof, you didn't complete it. Oh, this is the point I missed. That's why I could not complete that proof. I should have thought of this. I should have observed this particular fact, etc. So slowly you will learn that. Okay, again, this is you need to practice. Okay, start with some simple. Try to spend some time, 5 minutes, 10 minutes, 15 minutes, depending upon your time availability. Okay, at least you should make some attempt. Okay, very serious attempt. Not naam ke vaste, just do something and give up. Do something. Okay, and after that you open a book or class notes, try to understand. Okay, then you will see what are the points you missed, what you could have observed. If AP is a continuous function and closed and bound on double, then I know I should have used some theorem. Right? That theorem didn't occur to me. Then why did I do that? Okay, this is the kind of thing. Okay, so then you will, that kind of introspection makes you a better problem solver. Okay, and again, if you notice, you will see that in about maximum 2 to 3 months time, you will see that you will be able to quickly come up with some basic ideas, outline of the solution or outline of the proof, even though you may not get 100% correct. When you read, you will understand much better, and you will be able to reproduce or writing, etc. will also improve. Okay, so the basic thing is very important. Okay, make an attempt, and depending upon your time constraint, spend some time on that. Okay, but don't do for everything because you won't have time. Okay, times we all have only 24 hours. There are 5 courses, and every teacher believes, okay, we have only that course, nothing else in the under the sun. Okay, I know, I'm a teacher, right? I was at least. Okay, so they don't realize the students' problem, and they also are young, so there is social life for them. So it's difficult. So you spend some time, but you will see success rate improves a lot. And second thing, this nobody points out this. Okay, I am going to make a very categorical statement. Any problem, 95% of the time are accessible to routine thinking. That means it's a kind of if you practice, okay, you will be able to solve very high percentage of problems easily. Only very few problems will require some trick, some ingenious twist, okay, that kind of thing. Okay, 95% of the problems, okay, by simply digging at it, you will get it. How fast you get depends upon your practice. If you practice a lot, you will see your success rate will be faster and higher, and your solution speed will also be faster. So do that.
Meaning, sir, you are telling that by seeing those proofs, we generate ideas that if we are given something or we have to prove something,
No,
we have some
Abhishek,
ways.
I think you have taken a lot of time. Even your earlier proofwriting question was also from you, right?
Yes, sir. Yes, sir.
Yeah, so one should not spend too much time, but you should think about, okay? Other, right?
No,
Think
sir.
about that.
That proofwriting question is going
No,
not.
you give me an example. You give me a proof. You give me this theorem. You learned this proof. Tell me. Now I will demonstrate it to you.
Fundamental theorem of arithmetic, sir. Very famous theorem.
Okay. Oh, very good. So, what is the difficulty in that proof?
That, sir, how
No, you tell me the idea. Tell me the idea of the proof.
induction, sir. First,
Okay, see, that's again a wrong thing. You ask how number theory, guys, they will say this is induction. Is that the induction, usual induction?
no, sir. Strong
What
method.
belongs to that? N is true, n plus 1 is true. Is that the induction you are using?
No, sir.
So,
That
why?
is strong
Now, the
method
next question is, why I have to use that? If you understood, then you can write the proof easily. That's the idea. See, the point is, if you give me a number, a natural number, right, other than greater than 1, then either it is a composite number or it's not, right?
Yes, sir.
Either it's a prime or a non-prime. You understand that?
Yes, sir.
Yes? You follow that? If it's a prime, nothing to prove. If it's not a prime, then it's a composite number. Therefore, I can write it as n as a times b. And a should also be less than n. B also should be less than n. Therefore, I can apply the general induction, what teachers call strong induction. For me, it's a weak induction. I can apply to a and b. A is a product of prime. B is also a product of prime. Proof is over. Do you understand? Now you can write line by line proof, but that's the way I look at it. Okay, what is the basic idea? I want to write it a product of primes. If it is already a prime, nothing. If it's not a prime, that means the product of two numbers. But each is less than n. But standard induction will not say it's nothing to do with n minus 1, no. But a is less than n, b is less than n. Therefore, I use the other induction principle to say that a is a product of prime, b is a product of primes. You see that? That's the way you learn the proof. Now you read the proof, you also learn how to write it. That's it.
Yes, sir.
But that was too easy.
Yes, sir.
Yeah. But anyway, we should give chance to others.
Yes, sir. Okay. Thank you, sir.
Yeah. Now you saw that such a long proof, it just depend only on one single idea. And you also forced to understand why I have to use the other induction. Yeah, Chandra Prakash, you may call somebody else.
The audience may raise hands, those who wish to ask questions, interact with us. I have seen a lot of questions in the Google form that I circulated, but nobody is willing to ask here.
Okay.
Why is that? Please ask questions. Harini. Yes, please. Go ahead.
Harini.
Good morning.
Good morning.
I was reading your linear algebra book, and when we came to a few topics, and while giving examples, you highlighted examples that involved analysis as well. So,
Yes.
but while studying the subject in regular college, we couldn't understand the importance of bringing examples from other subjects so that the understanding is better in this subject as well as that subject.
Correct.
So, how important do you think it is to interweave subjects while learning, sir? Because that was something new I learned from MTTS. So,
Yes.
to a student who does not have that exposure yet, what would you suggest to do?
Yeah, it's a very good question that touches upon one of my tenets. Okay. I hate any book and anybody says my book or my lecture will be self-contained. Okay. It's simply not true. Nothing is self-contained in the world. Neither your life, nor my life, nor any subject, nor anything. Okay. So it's good to learn other things. And as you rightly observed, if I give examples from other field, you also understand other field well, this field also well. So simultaneously, you are understanding both better. And remember, mathematics is essentially a single unit for various reasons we break it into algebra, linear algebra, analysis, real analysis, complex analysis, topology, metric space, geometry, Euclidean geometry, non-Euclidean geometry, differential geometry, Riemannian geometry, and so on and so forth. Okay, but that is because each such topic theme, okay, has its own peculiar way of thinking. For that reason, we do that. But if you want to be a mathematician, at least some of the basic subjects like number theory, algebra, linear algebra, real analysis, okay, basic topology, complex analysis, all these things, you have to learn it as a single unit. So you should thoroughly use. In fact, if you look at any of my books, you will see I will be using okay, almost every part of mathematics in that. I have not tried to see only one small thing. Okay, what I usually call, have you seen horses? They will put like this. They will call it blinkers because this one does not allow the horse to see other side. Okay, if there is a grass on the right side or left side, it may drag the wheel. Okay, the chariot to that side. So you just put only this way. Okay, I don't like this kind of compartmentalized way of learning mathematics. You are right. So when you learn, also you learn to do that. If you look at my algebra way of teaching, I will do analysis. When I do analysis, I will bring algebra. When I teach topology, I will bring analysis and algebra. Of course, geometry. So that's the best way of learning, so that you become comfortable. Is there anything else more you wanted, Harini?
Sir, actually, yeah, so when we access your books, we'll kind of like learn to train ourselves. So, is that the way you want? Like, for example, if I want to tell my juniors that they can also learn the subject this way, so should I suggest to
Yes.
like read your book, or that is what?
Yeah, if you care for your children, your juniors, yes, you should do it. Okay. If you don't want them to learn well, then you don't want to.
No, sir.
That's
No,
what
I wanted to like, is this the right way? Is what I
In
want.
fact, this will be because it will be a motivation for them also. All right.
Yes, sir.
For example, say they will simply say F is continuous, G is continuous, A plus G is continuous, then C times F is continuous. Once you say, okay, that shows that continuous functions from a vector space, that makes more sense to me, right? I also understand vector space because vector space, it does not have to be something like what you think of physical vectors, right? Fine. Okay. Now you understand this is something much more. So it enhances your understanding, deepens your perspective. Yeah.
Yes. Thank you, sir.
Chetan Malik.
Please go ahead. Please go ahead, Chetan Malik.
Maybe he's out.
Anybody else? Please raise your hands.
Ved Prakash also said something on proof. Yeah. Ved Prakash Mishra, my answer to Abhishek, I answered on 2 different occasions. Are you there, Ved Prakash?
Yes, sir.
So, did I give you some tips for proof writing?
Sir, I wanted to know about the writing of proofs of very fundamental results, which seems very obvious, and I sometimes thought there is no need of proof it. So,
Nothing is obvious. Nothing is obvious for me. Okay? In science, nothing is obvious. You tell me what you found to be obvious, let me ask you. Suppose if I say, you ask our guy Chandra Prakash, he will tell you. A is less than equal to B, B is less than equal to A equal to B is obvious to you, right? Is it or not? Is it not?
Yes, sir.
No.
Yes, sir.
It requires proof. Can you tell me why? See, this is the kind of bound and duty of teachers. Okay, teachers also what they do, they look at a book, okay, they understand because of their experience, then explain line by line quickly and go away. All through life, even PhD student I asked, prove it. They don't think there is a proof. They think it's obvious. It's not obvious. How can it be obvious? You are using something about real number system and logic. Okay? You have to use law of trichotomy and logic also. When I say A is less than or equal to B, it's a combination of two statements. A equal to B or A less than B. When I say A is less than or equal to B is true, that means are you able to hear me now? I think I lost my connection.
No, sir, you are perfectly audible. So
yeah, okay. So when I say A is less than or equal to B, it's a true statement. That means it means two things. One of them must be true. Again, A equal to B or A is less than B. And law of trichotomy tells me that only one of them can be true. You understand? So if when you say A is less than or equal to B, sometime when I say A is less than or equal to B, A equal to B or A less than B, both may be true. In this case, law of trichotomy tells me it cannot be. Only one will be true. Either A must be equal to B, in that case we have proved, or A is less than B. Now come to the next one. You say B is less than or equal to A, and B equal to A is not allowed because A is not equal to B. Therefore, B must be less than A, but that's a contradiction. Again, law of trichotomy says A less than B and B less than A. Both cannot be simultaneously true. You see that logic is needed. How many times I use logic? How many times I use law of trichotomy? You think it's obvious? Ved Prakash? You think it's obvious? Yeah.
No,
This is the kind of thing teachers can do human service. They themselves should ask themselves, is it obvious? How will I explain my students? You are all budding, prospective teachers. Please think about like that. Then you will understand what is bothering and how logic is very important, how the concepts are important. See, nothing can prove the importance of logic and law of trichotomy here. And if you have any doubt, you ask your senior students, MSc, PhD students, ask them to, is it obvious? Can you give a proof? You will see how many struggle. Okay, right. Anybody? Chetan, was it Chetan who asked earlier? Hamra Ali.
Good morning, sir.
Yeah, Chetan, yeah.
I lost my connection earlier.
Yeah.
Sir, the major thing is when we go through some theorems in real analysis or some questions in group theory, the converse always seems to be a bit of trouble. Like the first thing is whether the converse will be true or not. That is the first question that pings in our mind. And the second thing is if it is not true, then the counter example, many a times we don't get the counter example right at the moment. So what should we do for that?
Okay, again I will tell you a rule of thumb. Here, see, many teachers, they all live in their, when they were students, and their teachers said counter exams, otherwise a big deal, So everybody believes that counter exam is a very important tool for mathematics. The secret to counter exam is 80% of the time, the extreme cases will provide you counter exam. Finish. More than 80% sometimes. Certainly 80%. If you look for a theorem, if the converse is not true, then you look for the extreme cases. Then you will get a counter example usually. And second thing is, see, there are some counter exams which are very, very difficult, ingenious, you have to consult. But they are usually at a research level. But usually in standard courses, most of the time, 80% of the time, you can get a counter example by looking at extreme cases. For example, you say some theorem is true for group theory, right? For me, extreme examples will be, what will be extreme example?
Lins for group or quaternion group.
It all depends.
Yes.
Because quaternion is, we have seen that, okay, the teacher asked, does there exist a group in which every subgroup is normal but not the group is abelian? Okay. This kind of thing, you simply made an observation. It's not, it's not that you constructed. You look for an example, okay, you look for this and you constructed it. No, it was already existent. Somebody had already observed that, so he made it. Okay, so you have to understand this kind of tricks. Okay, teachers and books play what do you call a con trick on you. The con trick is, I didn't construct quaternion just for this or something. 8 group. You understand? It was already there. Hamilton did. When I was doing group theory, I found this 8. Then I found every subgroup is normal. Okay, but it is not abelian. Okay. Then when abelian group, when I proved every subgroup is normal, then this example came to me. Oh, there exists a group in which it's not true. That's it. The group need not be abelian. So this example you didn't construct. It was already existent. Okay. Now you try to give it as a counter example. Yes. But don't think that you constructed just because of you to answer a converse. That's a mistake you are doing. And the teachers also do. Okay. Whereas I asked a question for which no existing thing was there, then I constructed. For example, there is invariant subspace problem. Okay, then somebody constructs. There is a in a functional analysis, there is some kind of existence of basis problem. Somebody constructs such problem. That is a construction. That's a counterexample. There are such things. Okay, these are not actually counterexample. You already know. You just pull it from your shell. Oh, this example. Look at it. This doesn't satisfy. That's it. Okay. Don't be intimidated by this kind of thing. Okay. You knew it and they used it rather than you constructed it there. Do you understand, Chetan, what I'm trying to say?
Yes, sir.
Right.
Thank you, sir.
Kumara, I has raised hand. Please ask the question.
Yes, sir. Good morning, sir.
Good morning. Can you speak a little louder?
Yes. Sir, I want to ask that after reading the theory, I am still facing problems in solving the questions. So, is it like we should go through the theory again and again to get it very clear, or there is something else that we need to look for in solving the questions?
Yeah, this question I already answered in a different way, but again I will answer it in a different way now. The first thing is, when you try to look at a problem, okay, you say that, should I go back to the theory? Perhaps yes. But then theory doesn't mean that you have to go through the proof there. You understand? When you read a theorem, this is the one thing which teachers also don't do. That in MTTS I always emphasize. When you state a theorem, don't jump into the proof. I hope some other teachers are here. They will use this idea. Don't. Okay. Don't be in a hurry. Whatever I remember, I have to prove it before the bell rings. The time is up. Okay. Don't do that. Try to understand. Spend more time on understanding the result than the theorem. This proof. Okay. What is the hypothesis? What is that I have to do? In what way I can use it? You may or may not get an application there, but try to use it. Then when you see a theorem, then you will remember that. I give you an easy example. Suppose I ask you to give a continuous function from the closed interval 0, 1 on to the positive reals. Okay? Have all of you done continuous function? Does this make sense to all of you?
Yes, sir.
Yes? Please say thumbs up if this makes sense to you. Okay, this is a problem. It's in my book also. Okay, give me a continuous function from the closed interval 0, 1 on to the positive reals. Now I may not know what to do with this. So I will not immediately start constructing. That's what many students do. Keep trying for half an hour. The first thing I have tried to do is, this is a continuous function. Okay, what is the domain? 0, 1. It's a closed and bounded. Therefore, is there any theorem or result which I know about such functions? Yeah. there is something like intermediary theorem. The other one is bounded. Any continuous function cannot be bounded. It also attains its bounds. These are the theorems I know. Can any of them be useful here? Now we'll go back to the problem. The problem says it is a continuous function from the closed and bounded over 0, 1 on to 0 infinity, on to positive reals. If it is on to, then the function cannot be bounded. Now I know how to write this solution. Do you understand? Okay, you give me some other result. Okay, suppose a very simple example I'm trying to give. So that the first thing is, whenever you read a theorem, okay, whatever is the hypothesis about the problem, you look at whether you know results which use that kind of hypothesis. Okay, for example, suppose I say, yeah, I want a group homomorphism, okay, from a group of order, okay, 17 onto a group of order 4. You understand this? How will I solve it? F of g, it will be 1, 2 or 4. Okay? But then the kernel must be a subgroup of 17. Group of order 17. What are the subgroups of order 17? Either it is trivial group or it's a full group, right? 17 is a prime number, right? Therefore, the kernel has to be either trivial group, in which case the function f will be 1, 1. But I have 17 elements in the domain, and the codomain I have only 4 elements. So it cannot be. Therefore, if it is 17, that means it's a trivial. Every element is mapped to identity element of the codomain. That means a trivial homomorphism. Therefore, I solve the problem. Do you see that? You just ask questions. There are numbers. It's not general group. Okay, G and H, 2 groups. No, I gave a number. That means number play a role. And you can immediately see 17. Oh, the 17 is something specific. It's a prime number. These are the things. So do I know anything? Then I remember it's a group homomorphism. How will I use it as a group homomorphism? The image and kernel are 2 obvious groups, subgroups which we associate with the group homomorphism. See, this is how we generate ideas. Slowly, if you practice, as I said, within a couple of months, you will be master at solving problems. Did this help you, these 2 examples?
Yes, sir.
Okay. So, to summarize, whenever you see a problem, okay, look at the hypothesis, look at the conclusion. Look for results which have some kind of relation to the hypothesis or relation to the conclusion. Then try to see that. Sometimes you have to reformulate. For example, the first example, f from continuous function from 0, 1 to on to positive reals, then 0 infinity, it's on to, that means the entire images are on to, therefore it's unbounded set. That thought should come to me. Okay, so if you keep on doing such things, it's just a matter of 2 months. Anybody can try to solve problems. As I said, 95% of the problems require only routine thinking, careful thinking of asking questions and what are the relevant results related to either the hypothesis or the conclusion which I have learned. That's it. Keep on asking. That's it. Okay. Next.
Please raise your hand to ask the question. We are nearing the end of the session.
Hriday.
Please go on.
Good morning,
Hriday or
sir.
Ridya?
Ridya.
Good morning, Ridya then. Okay.
Sir, I was in level 1 the last MTTS camp, and first of all, I would like to thank you, sir, because it has, as you always say, it has changed my view about mathematics. And even though I was not able to do so well in the camp, I couldn't go so deep in thinking as my other classmates usually did. But after the camp, I could see the considerable difference in my understanding, level of understanding. So, but still, just to mention, like this time also I cannot go so deep. I'm not able to ask so deep questions as you suggest even now. So I mean, am I clear, sir?
Very clear, Hridaya.
Okay.
Hridaya.
Okay, thank you,
All
sir.
right.
So I wanted to know that how can I develop the deep thinking? Can I just develop it by just practice or any other tip you have?
Yeah.
Uh,
The only tip is, as you said, practice. Okay, you keep on doing. See, as I earlier said about an hour ago, learning process varies from person to person. Okay, just because I am a slow thinker doesn't mean I am dunce. Okay, and just because the other person is a fast thinker doesn't mean he is always correct. Okay, so don't worry about that. Okay, keep thinking, keep asking questions, whether right or wrong. Keep asking slowly. As I said in MTTS camps, I would have said slowly you will learn how to ask correct questions and also how to answer them correctly. Okay, it only with practice. Okay, so some people need a lot more time. For example, most of the geniuses are okay are judged by their teachers as slow learners, but that's not true. Like Newton, Einstein, they are the best geniuses the world has ever seen. Okay, why are they then considered as slow learners? Because those people, when you ask something, they think about other ramifications of the problem, related problem. Also, they'll be thinking. Okay, so they don't want to immediately solve that problem alone. Okay, that is why they. So the teacher, he wants what is 4 plus 5. He wants. Okay, he wants to say whether I can do something more. That's what geniuses always try to think. Something much more general framework. Can it answer this in a much better way? So they take time. Okay, so naturally it may be a slow process. So it may be good, something similar to you. So don't worry. Keep asking questions. Okay, the simplest question I asked is this: look at the hypothesis. Have I seen results related to the hypothesis? Look at the conclusion. Have I seen results related to the conclusion? How to use that? Either any information, whether the hypothesis or the conclusion can be reformulated in a different language, in my own language, so that that may trigger my memory. For example, I said positive real it's unbounded set. Then immediately I continuous function bounded. It made sense to me like that. It just requires practice. So you are in level 1 this year, 2023, Hridaya?
Level 1, sir.
Okay. So keep practicing.
Yes, sir. Thank you.
You talk to your classmates also, okay, so that your thinking process sharpens. This
Sure.
The one trick to all of you I will say is, okay, do not be, you compete with yourself, don't compete with your friends. Okay, I compete with myself. Where was I yesterday? Am I better today? That's it. Okay, naturally you will improve. Don't worry about others. Okay, so you see that just because you worry about that, that's why it holds you back from discussing your issues with your friends. Because you think either the student or your friend may learn better than you, or he knows better than you and hence he may ridicule you. I don't care. I want to learn. Okay, that is why Confucius said that. If you don't know something, if you are ignorant of something, you ask what it is about, then you are a fool for that second. Okay, if you are ignorant of something, you are afraid of asking so that you don't know, you are not ridiculed. You do not ask. Then you are a fool forever. That's what Confucius said 3000 years ago. Okay, so don't worry. Discuss. The more you discuss with your friends, you will see your deep thinking automatically comes. Okay, and that way math students are very bad. Look at US is a university, therefore it's not one of the ISER, etc. So there will be a lot of students in humanity sessions, right? Go and talk to them. They'll keep on yapping. They will be talking all the time to each other. How many of you do that? If you talk about that, it will be only about cinema. Right? Not even politics, nation, or science, or mathematics. Yeah? Try to talk. You learn a lot. It will also make you a better communicator. And once you learn how to communicate very well orally, your writing will also improve. Because, as I said, the better you understand. Yeah.
Yeah. In that, I would like to add something to, especially to students which who study in our university. That please make a habit after every class, especially in subjects involving pure mathematics and physics. You have to think about it. It will help if you do group discussion. If a group of 3 to 5 people, if you will do group discussions and try to understand that thing in multiple ways on the same day itself. And MTTS puts a lot of emphasis on this point. Okay, and let's start explain about it. So
Chandra Prakash, can I say something?
Yes.
Yeah. I would like you, those who want to learn mathematics, how to think mathematics rather than simply doing an accountant job, checking line by line, how to think mathematics, how to think of a proof in few steps, how to ask the correct questions. I would suggest you go to my video YouTube channel, take some topic, only sequences, continuity, or linear algebra, or linear maps, or metric spaces, something. Take only one topic, there will be about 5 to 6 to 8 lectures. Okay? Just because you have learned something, don't ignore. Go through it. Whenever there is a pause, review, proceed, stop there, try to think. Even if you watch 12 such videos with utmost sincerity, you will see the way you think mathematics, your understanding of mathematics, your art of asking questions, your art of solving problems will tremendously improve. Okay. This is a kind of advertisement, but I know I don't get paid. Okay. 380 videos, which by government standard will be 3 crore rupees worth, which was freely uploaded to the YouTube. So it's not advertisement for my own benefit.
Okay, please watch those videos. Okay. And yes, whenever we watch videos, try to get some credible sources. Okay. Either NPTL or self videos, NTTS videos are there. And there is, I think MTTS is organizing OFCM at this time, Online Foundation Course in Mathematics. Okay. And I hope that most of the students will apply for it. Okay. And we are nearing the end of the session. I had planned this session for 19 minutes or something. Okay. So, with your permission, sir, we'll begin to end this session, sir. Or would you like to add, you put some concluding remarks, or anybody else would like to ask some questions right now?
Yeah, before we conclude, I would like to thank Janman Vivechan and especially Chandra Prakash for this opportunity. I enjoyed every minute of this interaction, lot of good questions, and it's not only serves you, it will serve a lot of student community. Thank you very much for such a perspective and really insightful questions. Thank you, Paul.
We have with us Dr. Vivek Jain from Central University of South Bihar. He's going to do some concluding remarks and the vote of thanks. Please.
Thank you, Chandraprakash. I think I am audible to all of you.
Yes.
Yes, sir, you are audible clearly.
Yeah. So thank you for giving me this opportunity, and I really enjoyed this session from the beginning. I was here, and sir, this session means you are doing this work. I think from in the 40 years of your career, you motivated several students through this program MTTS, through your teaching, and these students you have changed the way of their thinking also, how to think mathematics, how to do it. And not only that, these students now become faculty somewhere, and now they are changing the thinking process of their students. So it is a chain. It is a chain process like that.
Thank you very much, Dr. Jain.
I also want to become a student of you in MTTS program, but when I just know about these things, then I was not in in the final of MSc, so I could not join this program. But I used to motivate the student to join this program, because whenever I see their faces after coming from the program, they have a lot of differences.
Thank you very much.
I used to hear from them that what you have done there, what was the process there, so that I can learn something and I can apply it to my own teaching. This is the thing. And yes, you mentioned several things during this session, and I would like to summarize some of the things which you have mentioned. People should know and always keep in mind these things. And first of the thing is the attitude of the teacher is very important, which you have mentioned in your talk. Teachers should learn the subject well, and the main purpose of the teachers is to facilitate the audience for learning. Yes, right. This is very main thing. And writing proof is an art. This is, as you have mentioned in your talk. And we should motivate and ask the student to write small proofs first. That is very important. That is very important, because when they will be able to write the small proof, and then they can write the long proof. And for the long proof, as you mentioned, that break it into small steps and prove the small step first. Yeah. That is really important for the students. And example helps in understanding the concept and theorem. Right. Not only this, counter examples are more important.
Yeah. Exams are more important.
Yeah, counter examples are more important, because they help us to keep ourselves in a limit that you cannot go beyond that.
Right.
That increases our understanding. And one thing you mentioned is also important, that understanding the statement of the theorem first and then jump into the proof. These are the very main points, and the students should always keep in mind these things. Yes, sir. So now let me, thanks. Let me do my duty for which I am here. Let me thanks to Professor Kumaresan for giving their precious time to these students, and I also like to thank the students, participants here for joining it, because this program was for you all, and I hope that you have enjoyed and learned a lot of things with Professor Kumaresan. Thank you, sir, once again. Over to Chandraprakash again.
Just 1 second. Thank you.